All right, so we've got video 6 today. Today's work is review sheet 2, 16 to 23. We're going to do 17, 21, and 23 together. Starts out with the mean value theorem. Mean value theorem is on the front of the packet. So if a function is continuous and also differentiable, so continuous on a closed interval, differentiable on an open interval, then the slope between the endpoints is equal to the instantaneous slope, meaning the derivative at some point on the interval. So this square root is an issue any values less than 2, because it would make it negative under the radical. So we are continuous from 2 to 6. So we are continuous. We're good there. Differentiable. Most functions are differentiable on their domains, and square roots are true in that nature as well. So we need to find, with mean value theorem, you need to find the slope between your endpoints. So we know our x's of 2 and 6. Well, if you sub in 2, you'll get square root of 0, which is 0. If you sub in 6, you'll get square root of 4, which is 2. And then we'll do 2 minus 0 over 6 minus 2. Note that 2 is the y value 2 on top, minus the y value of 0. So this will give us 2 over 4, or in other words, a half. Now we need our derivative. We've got to do a chain rule. We'll have 1/2 out front, x minus 2 to the negative 1/2, then times the derivative of the inside, which is 1. Now we want to neaten this up. This is really 1 over 2 radical x minus 2. So we take our slope between the endpoints, set it equal to our derivative. If we cross multiply, we can then divide both sides by 2. We can square both sides to get rid of the radical. And if you add the 2 over, you get x equals 3. Now, if you'd gotten multiple answers, we would want to check and make sure it's in our interval. Now, I would say still check and make sure it's in your interval, because if you get one value and it's not in your interval, then you know you did something wrong, because mean value theorem guarantees you should get at least one value of x where our slope between the endpoints is equal to our instantaneous slope, the slope of the tangent line at some point on the interval. All right, next we're going to look at 21. So we've got a limit. Usually the first thing you do with a limit is try direct substitution. Well, sine of 0 is 0. 0 minus 0 is 0. 0 cubed is 0. 0 over 0 is an indeterminate form. Our indeterminate forms that tell us we can do L'Hopital's rule is 0 over 0, or any type of infinity over any type of infinity. The other ones that you could run into, if you have 0 times one of the types of infinities, you'll have to move one of them to the denominator, and it should turn into a L'Hopital's case. Or if you have an infinity minus infinity, get a common denominator and bring them together, and it should also turn into a L'Hopital's case. So we are going to do L'Hopital's rule. Make sure you rewrite your limit. L'Hopital's, you take the individual derivatives of top and bottom and reevaluate. So we'll have cos x minus 1 over 3x squared. If we sub in 0, cos of 0 is 1. 1 minus 1 is 0. 3 times 0 squared is 0. So we'll go ahead and do our L'Hopital's again. So cos's derivative is negative sine x. Derivative of negative 1 is 0, and we will have 6x on the bottom. Well, sine of 0 is just a 0 again. 6 times 0 is 0, so we'll do another L'Hopital's. Negative sine's derivative is negative cos. 6x's derivative is 6. When we do direct substitution, we get negative 1/6. And what that means is in the original limit, as x approaches 0, the y values are approaching negative 1/6. All right, and we'll finish off this video with 23. We're going to find intervals of increase, decrease, the x values of maxes and mins, intervals of concavity, and x values of inflection points. Always look and see what type of graph you're given first. We've got an f prime graph. Notice in 22 it's an f graph, so you'll be looking for different things. So in an f prime graph, the y value in the f prime graph tells us where the original graph increases and decreases. When a derivative is positive, that means the original is increasing. When the derivative is negative, that means the original is decreasing. So the first section we have is a negative section. So from negative infinity to negative 6, we have a decrease section. And then from negative 6 to negative 3, we're above the x-axis. So that's an increase section. Then from negative 3 to negative 1, we're below the x-axis. So that's a decrease section. From negative 1 to positive 3, we've got an increase section, and then we've got another increase section from 3 to infinity. And B, x values of maxes and mins. Well, once you have your increase-decrease intervals, I would say just look at those. So we start from negative infinity to negative 6. So at negative 6, it switches from a decrease to an increase. If you go decrease to increase, that's a minimum. Then negative 6 to negative 3. At negative 3, we're going increase to decrease. Increase to decrease is a maximum. Negative 1, we again go from decrease to increase. So that's back to a minimum. Then at 3, it doesn't switch, so nothing is happening there. All right, intervals of concavity, concave up and concave down. Concave up is when the second derivative is positive. Well, if you have a first derivative graph, to find information about the second derivative, you always look at the slope to find information about the next derivative. So whenever the first derivative slope is positive, that's when the second derivative will be positive. So we start out with a positive slope here. So the original graph will be concave up from negative infinity all the way to negative 4. And we have a negative slope from negative 4 to negative 2. And we've got a positive slope from x equals negative 2 to 1. Then a negative slope from 1 to 3. And then a positive slope from 3 to infinity. And then lastly, the x values and the inflection points. That's when it changes concavity. So we started out concave up, it switched at negative 4. Negative 2 we switched. Positive 1 we switched. And then positive 3 we switched as well. So we had 3 x values of inflection points in the original graph. Okay, so finish the rest of 16 to 23 and submit your work.